We'll be looking at theories or hypotheses of enzyme catalytic mechanism. Some scientists, they sat down and they observe how enzymes catalyze chemical reactions. They look at how the rate of chemical reaction is enhanced. Now, the theories or hypotheses of enzyme catalytic mechanism, there are many. But we'll look at these four main types. Now, the first one here is proximity and orientation theory. You agree with me that if this is an enzyme, the site of the enzyme where the substrate binds for catalysis to take place is called the what? It's called the what? The active site of the enzyme, right? Good. Now, you were told that one feature or one property of an enzyme is that enzymes are specific in action, right? Enzymes are specific. What does that mean? They are selective in action. An enzyme cannot catalyze all substrates. Now, for an enzyme to catalyze a particular substrate, that enzyme must have the same shape as the active site, right? The shape of the substrate must fit into the active site, so catalysis can take place. If it does not fit into the active site, can catalysis take place? No, right? Now, the proximity and orientation theory states that for enzyme catalysis to take place, the enzyme and the substrate must be close enough to each other. Are we getting it? The enzyme and the substrate must be close enough to each other, and not only close enough, but they must orient themselves in the right angle or position. You know, proximity, we're talking about closeness, right? It's just like you want to grind cassava, and the machine, the grinding machine is the enzyme, the cassava is the substrate. Then you now keep the machine here, you keep the cassava here. Will this machine grind the cassava? No, right? It will not grind until you carry the cassava and put in the machine. So they must be close enough for catalysis to take place. And not only close enough, the substrate must orient itself in the right angle or position. Take for example, you want to grind the cassava, but you now place the cassava on that place that they used to hold. That place they used to hold and push. Not in the greater part of it, the greater, that one is rotating. With the cassava, with the machine grind, no. This substrate is close to the enzyme, right? They are close or in proximity. But now, instead of turning this way so you can fit into the active site, is backing the enzyme. Will catalysis take place? No. So the proximity and orientation theory proposes that for enzyme catalysis to take place, the enzyme and the substrate must be close enough to each other, right? In fact, the closer it is, the more the reaction. And it not just close, but orient itself in the right angle or position. All right, that's that. Now, the second theory is the strain theory. In some places, you see it as a strain effect. So whether you see strain theory or strain effect, is the same thing. Now, the strain theory proposes that if we have an enzyme here, and an enzyme, the substrate binds to the enzyme. If substrate binds to enzyme, what are we going to have? Enzyme substrate complex, right? Good. Now the strain theory proposes that as the substrate binds to the enzyme to form the enzyme substrate complex, as they come together, that there is a form of agitation, there's a form of internal stress or internal strain that will now change this substrate into products. That as the substrate binds to the enzyme, there is an internal strain, there's an internal stress caused on this substrate. So as they bind, this enzyme now will now change the conformation, change there will be a stress on this substrate, thereby changing it to product. Take for example, still your cassava grinder. If you put your substrate in the active site, that is that grinding part of the cassava, you agree with me that there will be an internal stress there, right? Converting the cassava tuber into the grinded form. Same thing is happening. That is the strain theory. That as the substrate comes in contact with the enzyme, that there is an internal stress changing the substrate to products. And the more time the substrate spends with the enzyme, the more the reaction. It's just like I hold the cassava like this and put in the grinding machine. If as I'm putting it small, it's grinding small, right? The more the reaction will be taking place because it's having contact. But if I just place and remove, as I remove, will it still be grinding? No be magic now. All right, so do we understand proximity and orientation theory? They must be close enough and in the right position or angle. Strain theory, as the enzyme and the substrate binds, there is a form of internal strain or agitation that changes the substrate to what? Product. Now, acid-base catalytic theory, acid-base catalysis. This theory proposes that enzyme catalyzed reactions either take the acidic route or the basic route. They are either acidic or basic or alkaline. Is it, we can use alkaline in place of basic. Now, you agree with me that enzymes are proteins, right? Enzymes are proteins. All enzymes are proteins apart from one. Which one? Who can get it right? All enzymes are protein apart from one enzyme. No. All enzymes are proteins apart from one. What is that? Ribozyme. All enzymes are proteins apart from ribozyme. Now, but that's not the topic of discussion. Now, acid-base catalysis, you agree with me that enzymes are proteins, right? And the building block of protein is what? Amino acid. Now, some amino acids we have in the protein have acidic side chain. Take for example, if you have something like this. This is the structure of what amino acid? This is what? Aspartic acid, right? Aspartic acid. Now let's look at this. Let's assume that this is a base, right? This is an acid functional group. The effect of this base will cancel out the effect of this acid. But we still have another carboxylic acid here, making the total compound acidic. Same thing with glutamic acid. So if the enzyme have more of this, the reaction will be what? Acidic, right? Now, some of them are alkaline bases. Amino acids like lysine, arginine, even histidine, they are basic in nature. Now, acids are substances that do they donate proton or accept proton? They donate proton, right? Please, proton means hydrogen ion. Now look at this reaction. Among this and this, which one is the acid? HA is the acid, right? So this is the acid because it has proton, it can give out. Now if an acid donates a proton, has given out proton, is now this, right? Is now a what? Is this an acid or a base? Is this an acid or a base? Does it have hydrogen? It's a base now, right? It does not have hydrogen now. If acid donates its hydrogen, it becomes a base, a conjugate base. This is a base, right? Because it can accept hydrogen. A base is any substance that can accept proton. According to Bronsted-Lowry, Lewis defined it in terms of electrons. Arrhenius defined it in terms of dissolution in water. Now, if this is a base, if a base accepts hydrogen, it becomes what? Conjugate what? Acid. This is now an acid. Now it has this. Covalent catalysis. This is the fourth theory of enzyme catalytic mechanism. And you agree with me, among covalent bond and say van der Waals force, which one is stronger? Among covalent bond and van der Waals force, which one is stronger? We know van der Waals is a very weak force, right? When they say the bond between us is covalent, it means it's very strong. It's very strong. Like the one you police to say, Esther, I can die for you. The bond between us is Esther. That type of strong bond is covalent. Now, covalent bonds here, in covalent catalysis of enzyme catalytic mechanism, this mechanism proposes that the bond between the enzyme and the substrate to form the enzyme substrate complex is a covalent bond, meaning that for catalysis to take place, the substrate must bind to the enzyme very tightly. Do we get? The substrate must bind to the enzyme very tightly for catalysis to take place. So, as the enzyme binds to the substrate, it binds with a covalent bond for catalysis to take place. Do we understand that? If you are asked to write on the theories, give them this. Any questions so far? No question, right?